So today we're going to be doing a couple problems with force. We're going to start with normal force. The problem is a 36 kilogram box stands on a pedestal. Part A, what is the normal force acting on the box? Part B, suppose the box was cut in half. What would be the normal force for a single box? Now let's start with the diagram. We're going to start by drawing the pedestal with the box on top. Normal force is going to push up, while gravitational force is going to counteract that, pushing down. For part A, because the box is sitting on the pedestal, the normal force equals the gravitational force. You can replace mg for fg. Then substitute the values for m and g. The mass is 36 and g is 9.8. Then multiply them to get the product 352.8 newtons. For part B, you can again start with the statement Fn equals Fg. This time, instead of just subbing in mg, sub in 1/2 mg. Then sub in the same values for m and g. And you get the products 176.4 newtons. The second problem we're going to be doing today is frictional force. So the problem is a car is dragging a 2,000 kilogram trailer and is moving the trailer onto a side yard. The coefficient of the rubber tires on grass is 0.35. What force opposite to the frictional force needs to be provided by the car engine for the trailer to move? So let's begin with the diagram. So you're going to have the trailer pulled by the car, which is the force applied, and that's going to go against the frictional force. And you're going to start the math with net force equals Fn minus the force of gravity plus applied force minus frictional force. The net force equals 0 because there is no acceleration, so you can add gravitational force and frictional force to the other side. Because gravitational and normal force equal each other, you can sub in Fg for Fn. Then you can subtract Fg from both sides, so this leaves you with Ff equals Fi. Ff equals umg, so you can sub that in and sub in the values for umg. U is 0.35, mass is 2,000, and g is 9.8. Multiply them together to get the product 6,860 newtons for applied force. Our next problem we're going to do is tension. John is standing on top of the Empire State Building with 25 of his favorite jump ropes tied together. He ties a 5 kilogram toy car to the rope and lowers it down. The acceleration is 3 meters per second downward. What is the tension in one rope? So let's start with the diagram. So we have the building with a rope with a toy. Now for the math, we're going to start with net force equals the force of tension minus the force of gravity. Net force equals ma, so we can sub that in and keep Ft and sub in mg for force of gravity. The mass is 5, so we can sub that in, and the acceleration is -3 since it's going downward. Keep Ft and sub in 5 for mass, and 9.8 for J. Multiply each to get negative 15 equals Ft minus 49. Now add 49 to both sides to get 34 newtons equals Ft. The last problem we're going to be doing is gravitational force. So the problem is, Emily is on a bathroom scale in a motionless elevator. When it begins to move up, she is now 1.5 times her normal weight. Calculate the acceleration and direction of the elevator. So we're going to start with the diagram again, and we're going to draw the scale with the person, and draw a box around the person to show the person as a whole. And normal force is going to act up, while gravitational force acts down. So for the problem, we're going to start with net force equals 1.5 Fg minus Fj. We're going to sub in Ma for net force and subtract 1.5 minus 1 to get 0.5 Fg. We're going to substitute Mg for Fj. Cross off the m's on both sides and multiply 0.5 by 9.8 to get the product 4.9 acceleration.